Good day. The topic we are treating today is sequence by Opola Monsurat Olajumoke. In this lesson, the generalization and expansion of terms in a sequence are taught. By the end of this lesson, I hope you will be able to identify the general term of the sequence, expand and also expand the sequence to a given term. Sequences. A sequence is a succession of terms in such a way that the terms are related to one another according to a well-defined rule. The rules may differ depending on the arrangement of such terms. For example, we have the sequence 3, 9, 27, 81, 243 and so on. This is an infinite sequence. Here the first term is 3. To get the second term, we multiply 3 by the first term, which is 3, you get 9. To get the third term, you multiply 3 by the second term, 9, to get 27. To get the first term, you multiply 3 by the third term, 27, to get 81. To get the fifth term, you multiply 3 by 81, which is the fourth term, to get 243. So to get the sixth term, which is not given here, you multiply 3 by the fifth term, 243, to get 729, and so on. That is, it follows a general rule. That is, to get the next term, you multiply 3 by the preceding term. That is the rule of this particular sequence. The next sequence, 5, 9, 13, 17, 21. Here, 5 is the first term. So to get the second term, you add 4 to 5, you get 9. To get the third term, you add 4 to 9 to get 13. To get the fourth term, you add 4 to 13 to get 21. To get the fifth term, you add 4 to 17 to get 21. And to get the sixth term now, you add 4 to 21 to get 25, and so on. Here, the general rule of this particular sequence is adding 4 to the preceding term to get the next. For the first example, each term except the first is obtained by multiplying the term immediately before it by 3. And for the second example, each term except the first is obtained by adding 4 to the term immediately preceding it. Once the pattern of a sequence has been identified, that is, the general rule is follows, the next thing to do is to find a formula for the general term of the sequence. The nth term or general term of a sequence is usually denoted by t subscript n, and it is usually a function of the positive integer n. Positive integers are numbers ranging from 1 to infinity. The nth term must be in a way that it will be able to generate all the terms in the sequence as n increases. A sequence may be finite or infinite. In a finite sequence, n will have an upper value and Tn will be the last term of the sequence. Upper value in the sense that n will be finite. It will have a stopping point. Suppose n is 5 now, we have 5 terms in that particular sequence. We have T1, the first term, T2, the second term, T3, the third term, T4, the fourth term, and T5, the fifth term, which is the last term of that particular sequence. In an infinite sequence, there is no last term. There is no last term in the sense that n will not have a stopping point. It is infinite. It is to infinity. To generate the general term for the above examples, that is example 3, 9, 27, 81, 243 and so on, and 5, 9, 13, 17, 21 and so on. So for the first example, the first term is 3 and it can be written as 3 raised to the power 1. That is the number of term you are in. You know, here you are in the first term, you raise 3 to the power of 1, and that is 3. 3 raised to the power 1 is 3. The second term is 9, that is, you can write it as 3 raised to the power of 2, where 2 is number of time you are in. 3 raised to the power 2, which is 3 multiplied by 3 to give 9. The third term is written as 3 raised to the power of 3, the term you are in, 3. The first term raised to the power of 3, that is the term you are in, 3 multiplied by 3, 9. 9 multiplied by 3 will give 27, which is the value of the third term. The fourth term, the same thing is also applicable to the fourth term. So now we move to the general term of that particular sequence, which is t subscript n, which is 3, which is what we have here. It's common to all the term, raised to the power of the term you are in, which is n. So your general term, the nth term of that particular sequence, the general term the sequence follows, the general formula it follows is 3 raised to the power n. So to check if this satisfies the sequence, you start by substituting the value of n starting from 1, since n are positive integers, and positive integers are numbers that start from 1 to infinity. So you substitute the value of n to be 1, t1 equals 3 raised to the power 1, which is 3, and that is what we have here. t2 equals 3 raised to the power 2, which is 3 multiplied by 3, which is 9. t3 is 3 raised to the power 3, which is 3 multiplied by 3 multiplied by 3 to give 27, and that is exactly what we have here. t4 equals 3 raised to the power 4, which is 81. So this particular sequence satisfies the term, therefore it is the nth term or general term of that particular sequence. So if you are asked to find the value of t20, you know, when your n is 20, you have t20 equals 3 raised to the power 20, which is 3 multiplied by itself in 20 places. Now we move to the second example. Here, the first term, which is 5, can be written as 5 plus 4 multiplied by, you subtract 1 from the term you are in. You know, in that particular sequence, you have to add 4 to the preceding term to get next, and that is how we obtain this particular 4. So we have to manipulate it in such a way that you get the value of that first term to be equals to 5. And for us to get the value of the first term to be equals to 5, you have to multiply 4 by 0 to give 0, and you add it to 5 to get 5. So if you want to use this to get the general formula, you have to subtract 1 from the term you are in, which is 1 multiplied by 1 subtracted from 1, you get 0. That 4 that you have to add to the preceding term to get the next, you multiply it by 0 to give 0. 5 plus 0 will give 5. So you move to the second one. You know, the second term is gotten by adding 5 to 4. So if you want to do it in this same format, you write 5 plus 4, you subtract 1 from the term you are in, 2 minus 1 will give 1, 4 multiplied by 1 will give 4, 4 plus 5 will give 9, and that is the value for the second term. The same thing is applicable to the third term. 5, which is the first term, plus 4 multiplied by the term you are in, you subtract 1 from it, 3 minus 1 is 2, 4 multiplied by 2 is 8, 8 plus 5 is 13. The same thing too is applicable to the fourth term. So now we move to the nth term. You know, here originally you have your first term 5 plus 4 multiplied by, you subtract 1 from the term you are in, which is n minus 1. So you have 4 multiplied by n minus 1. So you open the bracket here following the rules of Bodmer's. 4 multiplied by n will give 4n. 4 multiplied by negative 1 will give negative 4. So here we collect the like terms. We subtract 4 from 5. 5 minus 4 will give 1 plus 4n. So to check if this particular general term satisfies the sequence, you start by substituting the value of n starting from 1. t1 will be equals to 1 plus 4 multiplied by 1. 4 multiplied by 1 is what? 4. 4 plus 1 will give 5. The second term t2, that is when n is equals to 2, we have 1 plus 4 multiplied by 2. 4 multiplied by 2 is 8. 8 plus 1 will give 9. t3 is, you know, n will be 3. 1 plus 4 multiplied by 3. 4 multiplied by 3 is 12. 12 plus 1 will give 13. And so on and so forth. So if you have to find t20 here, that is when your n is 20, it will be t20 equals 1 plus 4 multiplied by 20. 4 multiplied by 20 is 80. 80 plus 1 will give 81. So 1 plus 4n is the general term of the sequence 5, 9, 13, 17, 21, and so on. So now we move to examples. Examples. Identify the general term of the following sequence. The first one, 2, 4, 6, 8. Second one, 1, 4, 9, 16. The third one, 1, 2, 4, 8, 16. And the fourth, 3, 6, 10, 15, 21. And this is the UTME past question, UTME 1994. So now move to the solution of these examples. The first one, 2, 4, 6, 8. In the first example, the first term is obtained by multiplying 2 by the number of term you are in. 2 is the first term, so you have to manipulate, you have to check a way you are going to do it to get 2 as your first term. And if you want to get 2 as the first term, you have to multiply 2 by 1 to get 2, and that 1 is the number of term you are in, so 2 multiplied by 1 will give 2. The second term is obtained by multiplying 2 by the number of term you are in, 2 multiplied by 2 to get 4. The third term, 2 multiplied by the number of term you are in, 3 to get 6. The fourth term, 2 multiplied by the number of term you are in, 4 to get 8. So nth term, Tn now, is 2 multiplied by the term you are in, n, to get 2n. So to check if this general term satisfies the sequence, you start by substituting the value of n starting from 1 when n is equals to 1. T1 is 2 multiplied by 1 to get 2, which is what you have here. The second term, T2, 2 multiplied by 2 to get 4, which is what you have here, and so on. So if you have to get T40, that is where your n is 40, you have 2 multiplied by 40 to get 80. In the second example, if we look at the sequence, we can say that the sequence can be obtained by adding odd numbers starting from 3 to the previous term to get the next. The first term is 1. If you add 3 to 1, you get 4, which is the first odd number. If you add 5 to 4, you get 9, which is the second odd number. If you add 9 to 7, 7 is the third odd number, you get 16. And so on, where 3, 5, and 7 are the odd numbers being added successively to a term in the sequence to get the next term. But if we follow this kind of pattern, we will not be able to get the general term of that particular sequence. It will not follow a particular pattern. So now here, when we want to find T20, we don't have to find T19 before we can find T20. We just have to substitute the value of 20 straight here to get T20. But if you should follow that particular pattern, before you can get T20, you start from T1, T2, T3 up to T20. There will be no general formula for you to find it. You will not be able to input the value of n straight and find the number of that particular term. So you will not be able to get the general term of that particular sequence. So the only way to obtain a general term for that sequence that can generate the sequence is by multiplying the number in each term by itself. Like the first term here, you multiply the first term, which is 1, by 1. 1 multiplied by 1 will give 1. The second term, the number of term you are in, 2 multiplied by 2 will give 4. The third term, 3 multiplied by 3 will give 9. That is 3 multiplied by itself. The fourth term will be 4 multiplied by 4 to give 16, which is the first term. So if you want to get the general term now, which is T sub 21, to be the term you are in, n multiplied by itself. So n multiplied by n is n squared. So you can find T100 even without finding T99 here. T100 will be equals to 100 squared, which will be equals to 10,000. So that is the usefulness of general term. You find a particular term even without knowing its preceding term. You can find T1 million here without knowing the preceding term of T1 million, of T999,999. Now we move to the third example. In the third example, the third example is 1, 2, 4, 8, 16. In the third example, we observe that the first term can be written as 2 raised to the power 0. 2 raised to the power 0 will give 1, and other values of other terms are multiples of 2. So that is why we use 2. 2 raised to the power, you subtract 1 from the term you are in. 1 minus 1, 0. 2 raised to the power 0 will give 1. The second one, it is the second term, is equals to 2 raised to the power the term you are in. 2, you subtract 1 from it. 2 minus 1 will give 1. 2 raised to the power 1 is 2. The third term, is equals to 2 raised to the power, the term you are in, subtract 1 from it, 3 minus 1 is 2, 2 raised to the power 2 is 2 multiplied by 2 to give 4. The same thing is applicable to the fourth term, 2 raised to the power, the term you are in, subtract 1 from it, 4 minus 1 is 3, 2 raised to the power 3 is 2 multiplied by 2 multiplied by 2, which is 8. And the fifth term, which is 2 raised to the power 5, you subtract 1 from that term you are in, which is 5 minus 1, 4, 2 raised to the power 4 is 16. So to get the general term Tn will now be equals to 2 raised to the power of the term you are in, n, you subtract 1 from it, which is 2 raised to the power n minus 1. So if you want to check if this particular general term satisfies the sequence, let's start from when n is equals to 1, T1 is equals to 2 raised to the power 1 minus 1, which is 2 raised to the power 0, which gives us 1. You can see that these values are powers of 2. That is why they choose 2. They raise something to the power of 2, and to get 1 here, if you raise 2 to the power of 0, that's the only way to get 1. Raising 2 to the power of 0 is the only way to get 1. That is why they have to devise this method of subtracting 1 from the number of terms you are in. So to get T20 now, you know T20 will be 2 raised to the power 19 and 2 raised to the power 19. Now we move to the fourth example. In this example, if we look at the sequence, it's like adding natural numbers successively from 3 to the previous term to get the next. That is, you know, the first term originally is given as 3. If you add 3 to 4, if you add 3 to 3, you get 6. That is the first natural number. You know, we said we are starting from 3. If you add 6 to 4, you get 10. 10 to 5, you get 15. 15 to 6, you get 21. But if this is followed, if we follow this particular term, if we follow this particular pattern, we will not be able to get the general term. So to get the general term, we get the number in the term by adding 1 to number of term and also adding 2 to it. Then we'll multiply it together and divide by 2. Like T1 now, you know, the term we are in here is first term, which is the number 1 term. You add 1 to it, 1 plus 1 is 2. You also add 2 to it, 1 plus 2 is 3. 2, you multiply them together, 2 multiplied by 3 will give 6. 6 divided by 2 will give 3. So the second term, you know, the term you are in, the term 2, second term, you add 1 to it, 3. You add 2 to it, 4. 4 multiplied by 3, 12. 12 divided by 2 is 6. The third term, you add 1 to it, 4. You add 2 to it, 5. 4 multiplied by 5, 20. 20 divided by 2 is 10. So you do the same thing up to the fifth term. You add 1 to the term you are in, that is the term number 5. 5 plus 1, 6. 5 plus 2, 7. 6 multiplied by 7, 42. 42 divided by 2, 21. So to get the general term of this particular sequence, you know, in the term you are in, you add 1 to it. Here you are in the nth term, you add 1 to it. You add 2 to the term you are in, you multiply it together and you divide by 2. So now if you want to check if this particular sequence, if the particular term, this general term satisfies the sequence, we start by inserting the value of n starting from 1. Here when n is equals to 1, we have 1 plus 1, 1 plus 2, 1 multiplied by, we have 1 plus 1 is 2, 1 plus 2 is 3, 2 multiplied by 3, 6, 6 divided by 2 we give 3. So here if you're asked to find T20, that is when your n equals 20, you have 20 plus 1, 21, 20 plus 2, 22. So 21 multiplied by 22 divided by 2 will be like 21 multiplied by 11. And 21 multiplied by 11 multiplied by 11 is 231. So T20 is 231. The terms in a sequence can also be obtained by inserting different values of n from n ranging from 1 step size 1 to n. That is, n is 1, 2 to the stopping point of that particular n. You know, we already say n is a positive integer. That is, you can be given the general term of a sequence and you are asked to find the value of the terms in that sequence. So the example, write down the first 6 terms of the sequence Tn equals 1 minus 2n, that is the first one, and the second one, T substitute n is equals to minus 2 raised to power n. The general term, for the first example, we are asked to find the first 6 terms of the sequence 1 minus 2n. Here, we know that n will range from 1 to 6, that is, n will be 1, 2, 3, 4, 5, 6. The stopping point here is 6. This also means that T6 is the last term and 6 is the upper value. When we substitute n to be equals to 1, we have 1 minus 2 multiplied by 1, and 2 multiplied by 1 will give 2, 1 minus 2 will give negative 1. The second term will be 1 minus 2 multiplied by 2, 2 multiplied by 2 is 4, 1 minus 4 will give negative 3. The same thing is applicable to the third term, 1 minus 2 multiplied by 3, which is 1 minus 6, to give negative 5. The fourth term, 1 minus 2 multiplied by 4, which is 8, 1 minus 8 is negative 7. The fifth term, 1 minus 2 multiplied by 5, which is 1 minus 10, to give negative 9. And the sixth term, which is the last term, is 1 minus 2 multiplied by 6. 2 multiplied by 6 is 12, 1 minus 12 will give negative 11. So the terms of that particular sequence up to the sixth term is minus 1, minus 3, minus 5, minus 7, minus 9, and minus 11. So now we move to the second example. Here, we have the same upper value, that is, the same upper value is 6, and the last term is also T6, but the general term is different because general term is minus 2 raised to power n. So to get the terms in that particular sequence, we start by substituting the value of n starting from 1. We stop at when n is equals to 6. T1 will be minus 2 raised to power 1, and minus 2 raised to power 1 is minus 2. And minus 2 raised to power 1 is minus 2. T2 is minus 2 squared, which is minus 2 multiplied by minus 2. Minus multiplied by minus will give plus. 2 multiplied by 2 will give 4. Plus 4 is the same thing as writing ordinary 4. The third term is minus 2 raised to power 3, which is minus 2 multiplied by minus 2 multiplied by minus 2. So we multiply negative thrice. Negative multiplied by negative will give plus. Plus multiplied by negative will give negative. So 2 multiplied by 2 will give 4, 4 multiplied by 2 will give 8, and that is why we have negative 8 here. T4 equals to minus 2 raised to power 4, so you multiply minus 2 4 times, you multiply negative 4 times, negative multiplied by negative will give positive, positive multiplied by negative will give negative, negative multiplied by negative again will give positive, and 2 multiplied by 2 will give 4, 4 multiplied by 2 will give 8, and 8 multiplied by 2 will give 16. The same thing is applicable to the fifth term, minus 2 raised to power 5, which is minus 32. Also, the sixth term, we have minus 2 raised to power 6, which is 64. These are exercises to show if you really understood what we have been explaining. We have one of the past questions, UTM 704, question number 18. Next video will be on arithmetic progression and its properties with sample questions and solution. Please subscribe to our YouTube channel, like and share our videos. Thank you.